Hello everyone, and thanks for watching Edupedia World videos. In this session of atomic structure, we will start with some terms that we have to remember like isotopes and isobars. Alright, so we have already seen what we mean by atomic number and mass number. So the rest of the terms that we are going to study will be based on those two numbers, atomic number and mass number. So the terms that we will be studying today are isotopes, isobars. Now these two terms are quite important from your school examination perspective, alright, that is CBSE perspective. Apart from these two, we will also study some more terms, though they are not covered in your school syllabus or NCERT syllabus, and you might even skip them if you like. Okay, but it's always good to know some information. You might never know when you might find it handy. Alright, for example, we'll be studying what is isotone, isodiapher, and also what are isoelectronic species. Alright, so all these kind of species we'll be studying today. So let's start. First, what is isotope? They are atoms of same element having same atomic number but different mass number. Alright, that is, they have same Z but different value of A. Okay, that is to say, let's say atoms of same element. So if I have hydrogen, alright, so hydrogen is not always found in form where number of proton is 1 and number of neutron is 0. Z is equal to 1 and A is also equal to 1. I have other atoms of hydrogen present on earth, alright, present on earth, which has 1 proton but also 1 neutron. So A value is 2. And there is also another atom of hydrogen which again has 1 proton but 2 neutrons. Alright, so they are all hydrogen atoms essentially. And since they all have same atomic number, the number of protons is same in all three. And in their neutral form, number of electrons are also same in all three. Hence their chemical properties are going to be similar. So the water that we drink, H2O, is usually what we refer to this hydrogen atom. Okay, this hydrogen atom is also called protium. Whereas there is another hydrogen atom in this form. This is called deuterium, and it is often represented by letter capital D instead of H. Okay, capital D. So even this can form water, D2O. Just like H2O, it can form D2O, which is called heavy water, and it is often used as coolant in nuclear reactions. Alright, and this last atom, this is very rarely and only in trace amounts present on earth. It is called tritium. Okay, this atom of hydrogen is called tritium. Alright, so if you look at how much hydrogen is present on earth, so out of all the hydrogen which we find on earth, around 99.98% is protium. That is why we usually say that hydrogen means protium, or it means that number of proton is 1 and number of neutron is 0, because most of it is present in form of protium. Whereas you can say around 0.01% is present in form of deuterium, and what's left is tritium. Okay, and when we calculate accurate atomic masses, okay, for example, if you are asked to calculate atomic mass of hydrogen, when you know that hydrogen can be present in 3 different forms, what do? You take average of these 3 forms. Alright, for example, let's say if you have a total of 100 hydrogen atoms, so out of those 100, I know that 99.98 will be present in form of protium, which has atomic mass of 1. Alright, whereas 0.01 will be present in form of deuterium, which has atomic mass of 2, and rest, alright, how much is left? So approximately another 0.01, okay, is present in form of protium, which has atomic mass of 3. So out of 100, this is the division of mass. 99.98 atoms will be present with atomic mass 1, some with 2, and very small with atomic mass of 3. Alright, this 0.01 incidentally came out to be same, but tritium is present only in trace amounts. Okay, you can also ignore its percentage in fact. and you can take everything what's left as deuterium. Okay, so this average is what we actually assign as the atomic mass of hydrogen. Okay, and it will come out to be 1 point something, 1.008 or something like that, unified mass. Okay, so this is how you actually calculate atomic masses. So this is not only for hydrogen, but even for a lot of atoms, there are atoms present with same atomic number but different mass number. For example, carbon has 3 different isotopes. One is carbon 12, one is carbon 13, and another is carbon 14. Alright, similarly chlorine has 2 commonly known isotopes, chlorine 35, chlorine 37. Alright, so likewise a lot of atoms, even oxygen has different isotopes, nitrogen has different isotopes. So isotopes, just remember that they have same number of protons but different number of neutrons, as a result of which they have same atomic number but different mass number. Hence their weights are different, but their chemical properties are similar because they have same number of electrons. Okay, and this is quite an important term which you have to remember. Next that we have to study is isobar. So isobars are atoms of different elements. Okay, in isotopes we are talking about atoms of same element, but here we are talking about atoms of different element which have same mass number, alright, but different atomic number. Alright, that is same A but different Z. For example, argon has atomic number of 18, right? It is a noble gas. Okay, potassium has atomic number of 19 and calcium has atomic number of 20. So they all have different number of protons and hence different number of electrons. So they will have different chemical properties. In fact, they are different elements altogether because their atomic numbers are different. But they have same mass number. That is, argon, which has 18 number of protons, also has, alright, it also has 22 number of neutrons. So in all it has 40 nucleons, whereas potassium, which has 19 protons, has 21 neutrons. So again 40 nucleons, and similarly calcium has 40 nucleons. So they have same mass number. Alright, so their atomic masses are approximately same. So argon has approximate atomic mass of 40U. Alright, potassium has approximate atomic mass of 40U, and even calcium has approximate atomic mass of 40U. Alright, so these are not accurate atomic masses. For accurate atomic masses, you also take into account weight of electrons, and you also take into account average calculated using their isotopes, but approximately they have same atomic masses because they have same number of nucleons. Okay, so such elements or such atoms of different elements having same mass number but different atomic number are called isobars. Okay, so these are the 2 terms which you have to memorize even for your CBSE syllabus. Apart from that, some terms that we are going to study are isotone. Isotones are atoms having same number of neutrons. So again, these are atoms of different elements. For example, let's say you have carbon 14, another isotope of nitrogen, which is nitrogen 15, and oxygen 16, which we commonly know about. Okay, so isotope of carbon 14 has 6 number of protons, nitrogen has 7, and here oxygen has 8 number of protons. So if you calculate number of neutrons in each of these atoms, here carbon will have 14 minus 6. Alright, 14 is the mass number, that is neutron plus proton, and 6 is the atomic number, that is number of proton. So 14 minus 6 will give me number of neutrons. So 14 minus 6 is 8. Alright, similarly here 15 minus 7 is again 8, and here 16 minus 8 is also 8. So each of them have same number of neutrons. So such species, okay, or atoms of different elements having same number of neutrons in them are called isotones. Alright, likewise we have another term called isodiaphers. So isodiapher, now this term is going to be quite important from nuclear chemistry perspective, alright, or nuclear physics. So you will study this term in radioactive decay, alright, and nuclear chemistry, but it's good to know it from now onwards itself, alright. So what is isodiapher? They have different atomic number and different mass number, but they have same neutron excess. So what is neutron excess? Neutron excess is total number of neutrons present in an atom minus number of protons. That is, how much is the number of neutrons in excess of number of protons. Like if you remember, I told you that for smaller elements it is often found that number of neutrons is same as number of protons. Not as a rule, but it is often found to be true. Okay, but as you go higher up in your periodic table, you will find that there is big difference between the number of neutrons and protons present inside an element, and hence we define a new term called neutron excess. Okay, and this term you will later on find is related to the radioactive decay of that element. So this neutron excess is n minus p. So how do you calculate number of neutrons? I calculate number of neutrons, okay, by calculating mass number and subtracting it, okay, and subtracting atomic number from it. So A minus Z is number of neutrons and number of protons is simply Z. So this means A minus 2Z is the neutron excess in an element. So atoms of different element having same neutron excess or same value of A minus 2Z are called isodiaphers. For example, uranium, okay, it has 92 protons and 235 nucleons, and thorium 231, alright, it has 90 protons. So if you calculate number of neutrons on this uranium and in this thorium and subtract their respective number of protons from it, you will find that n minus p has the same value for the two. Okay, in fact you can try it right now. For let's say for thorium, I know that value of A, that is mass number, is 231 minus twice of Z, that is atomic number, 90. So 231 minus 180. Alright, and similarly here if you calculate it, A minus 2Z will be 235 minus 2 into 92. You will find that both these numbers come out to have the same value. Alright, so such species are called isodiaphers. Similarly, you have some starting elements, for example, say carbon, oxygen, nitrogen, alright, all these have same number of neutrons and protons. That is, this carbon has 6 protons and 6 neutrons. Again, oxygen has 8 protons and 8 neutrons, and nitrogen has 7 protons and 7 neutrons. Alright, so for all such species, you know that n minus p will always be 0. That is, they have 0 neutron excess. Okay, so you can say even they are isodiaphers, but we don't actually define the term isodiaphers for such species. Alright, but you can if you like. Alright, there is no hard and fast rule to it. Next, what are isoelectronic species? Now this is something that you might have already studied in chemical bonding, or if you haven't, then you must remember what is isoelectronic species. They are any species. They can be atoms or ions, that is charged atoms, which we call as ions. Negatively charged atoms are anions and positively charged atoms are cations. So any species, whether atom or ions, containing same number of electrons are called isoelectronic species. Okay, so same number of electrons means isoelectronic species. For example, neon, the noble gas neon has 10 electrons in all. Alright, it has 10 electrons in its neutral atom. Okay, and to achieve the same configuration, we know that the fluorine which is beside it acquires 1 electron. So F negative, the fluoride ion, also has 10 electrons. Similarly, the neutral oxygen atoms acquires 2 electrons to achieve the same number of electrons as in neon. So it again has 10 electrons. So all these three. Similarly, sodium will lose 1 electron to acquire noble gas configuration of neon, and magnesium will lose 2 electrons, aluminium will lose 3 electrons. So all these species will have total number of 10 electrons in them. So all these are isoelectronic to one another. Alright, so this is all that we have to study today. Okay, and until next time, And once again, thanks for watching Edupedia World videos.